Hey everybody, it's Dr. J, and today we are talking about a big boy, stoichiometry. Let's talk about chemistry. All right, so stoichiometry is basically we're going to take our balance equations and provide a relationship between our basically numbers of our reacting molecules and our product molecules. Now, what exactly does that mean? All right, that's a technical definition. What we really about to talk about today is mole to mole ratio. That's what I'd like to think about this stoichiometry stuff. It's a mole to mole ratio. So let's take a look at this photosynthesis reaction. All right, so we in chemistry, but let's do some biology. Okay. All right, just a little bit. So we understand with photosynthesis, we got carbon dioxide and water with some sunlight, right? Making oxygen and then in this case fructose, some sugar over here. Let's talk about right stoichiometry. Let's relate all this together. So we need to understand our chemical equation, right? As we mentioned before in our previous videos, we said that, okay, this coefficient means that I have 6 moles of CO2 molecules, all right, reacting with 6 moles of water molecules, okay, producing 6 moles of oxygen molecules and 1 mole of my fructose. So these coefficients, right, are going to give me a ratio, okay? And that ratio, right, can be determined using our masses in this case, right? So we look down here. This means that I got 6 moles of CO2, well, 44 grams, that's CO2. 6 moles of water, well, 18 grams of water. 6 moles of oxygen, well, that's 32 grams of oxygen. And then 1 mole of my fructose, well, that's 180 grams for this fructose there. Okay, so stoichiometry, we're basically able to do a couple different things here, right? And really the main thing we use stoichiometry for is that, for instance, what if I want to figure out how many moles of oxygen are in, this reaction if I got 10 grams of carbon dioxide, right? Or how much fructose am I going to produce if you give me 10 grams of water, right? That's what stoichiometry is all about, right? We could figure out these different relationships now, right, using stoichiometry. So we don't necessarily have to do this reaction. We could literally do some math and do it itself, right? So let me give you 4 steps here. All right, 4 steps to how you're able to calculate your mass and reactions. So basically, you're going to write your balance equation first. So with stoichiometry, you got to make sure that you always have a balanced equation. If your equation is not balanced, you're going to get a wrong answer. Okay. Second thing, you need to convert your mass, so whatever you're given, to moles. All right. Third thing, once you have this balanced equation, right, this is where we use that mole to mole ratio step to help me find the moles or whatever I'm searching for. Fourth thing, then we're going to convert our moles of the unknown to grams or whatever we're looking for. So it's going to look like this, right? You got a certain mass of A. You're trying to figure out mass of B. How are we going to figure out the mass of B? Well, I need to convert my mass of A to moles. Then I'm going to use this mole to mole ratio to help me get to the moles of my B. Then once we in moles of B, then I could just convert that using molar mass to the mass of B here. And this is essentially stoichiometry, y'all, because we're just using this mole to mole ratio to help me determine these different masses. So let's look at an example. Suppose that a particular plant consumes 37.8 grams of carbon dioxide in a week. What is the mass of glucose in grams, in this case fructose, but that the plant can synthesize from CO2. All right. So I'm going to talk about the 4 steps that I just mentioned here. So if we look at this problem, we have 37.8 grams of carbon dioxide, right? It's saying that this plant is able to consume this CO2 in a week. But we need to figure out, well, how much are we going to produce, right, from this 37.8 grams that's being consumed, right? Because reactants are being consumed, and then we shooting out those products, right? Shout out to LeBron getting a 50 on them, okay? So, first thing we're going to do here, we're going to write the balance equation. So we're going to have 6 CO2 plus 6 H2O gives me 6 O2 and then our sugar over here, right? So same balance equation from before. But let's talk about what we do from here, right? So we have our balance equation. Then we need to convert, in this case, our given, that's given in grams, to moles, right? So I'm going to convert 37.8 grams of CO2 to moles using, what is this conversion factor? Molar mass, right? Molar mass. So molar mass, once again, is going to tell me that 1 mole of CO2, there's 44 grams of CO2. Now, where did this 44 grams come from, everybody? The periodic table, I heard it out there. Yes, it comes from the periodic table. So I added 12 plus 16 plus 16. That's how we get 44. We're going to do the division here, and then I'm going to see that I got 0.859 moles of CO2. Now, here's the new step that's going to be new to everybody, right? Once you have it in moles, we can now use this balance equation that we did before to find the moles of our unknown using the mole to mole ratio, right? So I got my given 8.59 moles of CO2. We just calculated that. Now, let's use this mole to mole ratio to help me go from moles of CO2 to moles of my sugar, right? So what do we notice here, right? Is it think of this dimensional analysis, y'all. I said it wasn't going away. Moles of CO2, we understand that it needs to cancel out, right? Because we're trying to go to moles of C6H12O6. So our moles of CO2 will be on the bottom. The moles of C6H12O6 will be on the top. We got that. That's that's squared away. That's standard dimensional analysis. Let's talk about these numbers though. Where do I get this 1 and 6 from? Right? I get this 1 and 6 from my balanced equation. That's the reason why we had to balance this equation, everybody. You had to balance the equation in order to do this stuff. Right? So 6 moles of CO2, where we get the 6? The coefficient. Because there's 6 moles of CO2. We're literally getting this number from our balanced equation. So in this reaction, we got 6 moles of CO2. Well, we need to use this 6 moles of CO2. And then how much are we going to be producing? We're producing 1 mole of C6H12O6. Okay, cool. We're going to put our 1 mole here, right, of C6H12O6. And that's it. That's the mole to mole ratio step. So in order to go from 1 mole to another mole, we got to use this step. Because our units will cancel out, leaving me with the units I want on top. So we do our math here, and then I'm going to get 0.143 moles of C6H12O6. All right. So now I got the moles, my sugar over here. And then I need to convert my moles to grams. Now, how are we going to do that? How are we going to do that? Well, we know how to do this because it's molar mass, right? So the molar mass of C6H12O6 is 180 grams per every 1 mole. We multiply those together, and then it gives me 25.8 grams of C6H12O6. So basically, all this is telling me is that this plant can consume 37.8 grams of CO2 in a week, right? And once it consumes that 37 grams, right, we're going to produce, right, we're able to produce, if everything goes correctly, right, if everything works out, we're able to produce 25.8 grams of our sugar. And I didn't even have to do this reaction or anything like that. I was just able to do some math and figure that out. And that's what's so beneficial about stoichiometry, right? It's going to really save time. It saves us a lot of time, right? And we could, figure out a lot of different stuff just by using this. So, everybody, pay attention to these steps. Balance the equation. You're going to convert your grams to moles. And then you're going to use that mole to mole ratio to help you go from the moles you know to the moles you want to know. Once you got the moles that you want to know, then just convert that to grams. All right. And that's essentially what we're going to be doing going forward.